Alright class, today we're going to look at polar equations and graphs, the easier ones. So basically we're just going to look at circles and lines today, and circles end up being graphs where you just have r equals a number, or r equals a number and then cosine or sine of theta, and we'll see what happens with those. When you have lines, you get just theta equals a number, or you could have r equals number divided by either cosine or sine of theta. And we're going to look at each of these examples and what they look like. Alright, so first thing we're going to do is look at number 1, which is r equals 3. Now r equals 3 basically means there's a radius of 3, the angle doesn't matter. So that means at an angle of 0, I'm going to go out 3. At an angle of 30 degrees, I'm going out 3. At an angle of 60 degrees, I'm going out 3. 90, I'm going out 3. So hopefully you guys see, no matter what angle you choose, you're going out 3. And when you connect all those dots, you get a circle that is centered at the origin that has a radius of 3. So that's that one. Now, this one's a little different, so we're going to use a table real quick, although you don't have to do this as often. At 0, pi over 2, pi, and 3 pi over 2, we have to plug those in for theta here to see what r is. Well, when cosine is 0, cosine of 0 when you're over here is 1. So you get 3 times 1 is 3, because it's 3 times 1. At pi over 2, the cosine is 0, so we get 0. At pi, you get a negative 3 and then 0. So to plot this, at an angle of 0, we're going out 1, 2, 3. At an angle of pi over 2, I'm going out nothing. At an angle of pi, I'm going negative pi over 3, which means it reverses and goes back to that point. And then finally at 3 pi over 2, I would go out 0. So here's what happens. You actually just found the two endpoints of the circle's diameter, which means the center is going to be right there in the middle at 1.5. So that means that if you go up 1.5 and down 1.5, you will also have the rest of the circle. Now I want you guys to look at this for a second. Notice how the circle is to the right. We could have predicted that based on the equation. This is cosine, which means x, which means left or right, and since it's positive, it's right. Okay? And it's right by a diameter of 3. So this 3 is actually the diameter in this case when you are graphing these. Now you could always check on your calculator as well. If you go to your calculator and you go to mode and you switch your mode from function to polar, and I'm doing it in degree, you can do degree or radian. Function to polar though, that's the key. Turn that to polar. So go down, scroll, hit that. When you do that and you hit y equals, now all of a sudden your graph is graphing r equals. And you can type in 3 cosine, and then the nice thing is the button where it was x before is now a theta. You have to be careful about the window before you graph this though, because it depends on what mode you're in. I'm in degree mode, which means my angle should be between 0 and 360. My step should be about 7.5, 6, whatever. It means it's going to plot a point every 7.5 degrees. And then my window, I did this z squared, so that's what it looks like. And if you graph it, you get your circle right there. And sure enough, it is moved over to the right, and it is a diameter of 3. Okay. So then, based on that, let's try the next one. Of course, this always freezes on me. Here we go. Let's try to guess where this circle will be, because again, this is the same format as the last one, except for it's negative and it's sine. So since it's a 3, the diameter will be 3. It's in the sine, which is up or down, but because it's negative, it's going to be down. So my guess is going to be 1, 2, 3, which means the center is again at 1.5 away. So if I go 1.5 to the right, 1.5 to the left, and I'm looking at this tick mark and this tick mark to do that, I should have a circle down here, the same size. If you're not sure, let's graph it. Negative 3 sine theta. Graph. And sure enough, that's where it is. So hopefully you guys see the how that works. So those are circles. Now we're going to do lines. Lines are even easier. Now I'm telling you, and you can't graph this line on the calculator because it's just theta equals and we don't have that. But think about it, theta equals 3 pi over 4, so r doesn't matter. So that means if I'm at 3 pi over 4, which by the way is 135 degrees, I can have an r of this, I can have an r of this, I can have an r of this, that, any r possible. I can even have negative r's, which means it goes this way. So hopefully you see that just along this angle line, I could have any point possible, which means it forms just a line at that angle. So there you go. So when it's just theta equals a number, go to that number, that angle, and draw a line. Over here, we have r equals -3 over cosine theta. I don't like this format. I don't like things with division, so I'm going to multiply both sides by cosine, and this side also by cosine. So you get r cosine theta equals -3. Okay, you could do a table, but hopefully you guys just notice, what is r cosine of theta? It's x. R cosine of theta is x. So really this is a vertical line at -3. 1, 2, 3. So then you just do that, and there's the equation. Same thing with this one. I get rid of the signs by multiplying. R sine theta equals 2. Again, when r and sine theta are together, they form y. So really this is the horizontal line, y equals 2. My lines are a little off, but you know. And that's it. That's graphing, and you can type this into the calculator to double check. Let's say you're not sure. I wanted to check -3 over cosine theta. -3 divided by cosine theta. And there it is, a vertical line at x equals -3. So, anyway, that's what we're doing today. Just circles and lines. Homework should be pretty easy. Just keep practicing. Maybe try it without the calculator first before you type them in. See what you have, and go from there. I'll see you next time.